let's look at these two vector valued functions and compare their trajectories. Little r of t is defined for t greater than or equal to 0. So I'm going to plug in some values. R of 0 will be 0, -4, -8. R of 2 will be 2, 0, -6. R of 4 will be 4, 12, 8. Okay, let's look at capital R of t. R of t at 0 will be 0, -4, -8. I want to look at R of the square root of 2. Will be 2, 0, -6. And now let's look at R of 4. Or 2, R of 2. Four, 12, 8. Notice, based on the t values that I chose, the same points are on the graph. If you look at capital R of t, that's just a composition of little r of t with t squared. If you replace every t, so let t equal to t squared, then r of t squared becomes capital R of t. So they're going to have the same points. It's just the first one, if you plug in a t value, you'd plug in the square root of that same t value to get the same point. Okay, so it will have the same points that are on the graph. Okay, so now let's look at the velocity vectors. The velocity vectors are just, those are just the derivative of the position vector. So v of t, I'll say v of little r, will be 1, 2t, 3/4 t squared. And v of capital R will be 2t, 4t cubed, 3/2 t to the 5th. Okay, let's look at that common point. Okay, at that common point, the velocity, so for little r, it reached this point when t was equal to 4. So we're going to get a comparable speed at the point. We want to be able to compare the speeds at the point when they're at 4, 12, and 8. So v4 would be 1, 8, 12. Okay. If you actually want to get the speed there, that's the velocity. The speed's the magnitude of that. Which is approximately 14.5. Okay, so that's the speed of that first object that's moving along according to R of t. Capital, or V of capital R, let's look at 2 when it's at that same point and see what its speed is at that point. So V of R at 2 would be 4, 32, 48. Okay, so if we found the magnitude, which would be the speed of the second object, we just find the magnitude, which that one comes out to be approximately 57.8. Okay, so you could graph these velocity vectors in space, and you would see that one of them was going much faster. So as t's increasing, the other one's speed is causing it to trace through the trajectory faster.